If r vector is the vector function of a scalar t and r its module, which means module means if I take the modulus of this r vector, I am getting its magnitude to be r, right? And a and b are constant vectors, then we need to differentiate all these four parts with respect to the scalar variable t. तो इन सबको हमें डिफ्रेंशिएट करना है विद रिस्पेक्ट टू टी जो हमारा स्केलर वेरिएबल है, एंड यहाँ पर ए और बी जो है कांस्टेंट वेक्टर्स हैं. लेट्स स्टार्ट विद द सॉल्यूशन. प्लीज नोट दैट इफ आर वेक्टर इज एक्स आई प्लस वाई जे प्लस जेड के वेयर आई जे के आर द यूनिट वेक्टर्स, then its magnitude will be r, right? So taking its magnitude, that will be the square root of sum of the squares of these components, that is x square plus y square plus z square. So what will be r cube? This will be square plus y square plus z square, the power it becomes 3 by 2, right? If r is the square root of this sum, then r cube will be squares of the sum of these variables, the power 3 by 2, right? If r vector is this. So here this r is called the magnitude of r vector, or you can also write this as module, right? So first we need to differentiate this sum. So that is equal to differentiating the first term plus differentiating the second term. Right? So this is further equal to, okay, first function derivative of the second one plus second function derivative of the first one, that is 3 into r square into dr by dt. Differentiating the a vector, having its cross product with the second one, dr by dt, plus a vector its cross product with the derivative of the second one, so double derivative of r vector with respect to t. So this is further equal to writing first term as it is, and I'm writing the second term as 3r square into dr by dt multiplied with the r vector, plus, because dA by dt is 0. Why? Because as a vector is constant vector, right? Because it is the constant vector, so its derivative is 0. So this term is 0, and writing the last one, a vector cross product with double derivative of r vector with respect to time. So this is the required answer for this first part. Second, finding the derivative of these two terms. So that is taking the derivative of the first term and then plus taking the derivative of the second term. Dot product of a with r vector and multiplied with b vector. Alright. So first function derivative of second plus second function derivative of first, that is 2r dr by dt. This is a sign for multiplication. Let me write like this. Okay, plus derivating this one. Okay, writing the first function, taking the derivative of the second function, plus writing the second function and the derivative of the first one. So what is the derivative? Writing here dA vector by dt dot product with r vector plus a vector dot product with dr by dt, the derivative of r vector. Writing the first term as it is, plus writing here 2r dr by dt multiplied with r vector, plus, because b vector is a constant vector, so this derivative is 0, and also a vector is constant vector, so this derivative is also equal to 0, and now b vector is multiplied with the last term, so it is a vector dot product with dr by dt, because they are having their dot product together, and now b is multiplied with this. Is it okay? Fine. Okay, let's move on to the next part. Taking the derivative of product of r the power n and r vector. Okay, so writing the first function, derivative of second, plus writing the second function, taking the derivative of the first one, so it is n r the power n minus 1 and dr by dt. So we can write like this, writing the first term as it is, plus n r the power n minus 1 dr by dt. Please remember that always write this r vector after this. This is also okay, but you have to write, it is good to write r vector after this. Next, taking the derivative of the square of this sum. So this is equal to, when taking the derivative, it is twice of this complete bracket part and then derivating this complete part with respect to t. It is twice of a vector r vector plus r vector b vector multiplied with derivative of this, that is the derivative of first term plus the derivative of the second term. So writing twice of a vector r vector plus r vector b vector as it is, and now we are taking the derivative of this first term. So it is first function derivative of second function plus second function derivative of the first one plus derivating this first function derivative of the second one plus second function derivative of the first one. So twice of a vector r vector plus r vector b vector. Okay, a vector is constant, this term is 0. B vector is constant, this term is 0. So we have here a vector dr by dt plus b vector dr by dt. That's it. Reason you can mention over here. A vector is a constant vector, b vector is also a constant vector, so their derivatives are equal to 0. Alright, thank you.